You're listening to STP Radio. Welcome, STP Radio fans, to another episode of STP Radio with myself, Mark Tomlinson, your diligent and committed, not committed in a insane kind of way, host of STP Radio. I'm very excited to have a dear friend and actually someone I've given multiple interviews to for STP, once on one of my other Spreaker accounts and also recently on a Perf Bites episode. And this is a person with the best title I have ever heard still to this date, Principal Knowledge Engineer, part of the Engineering Excellence Group, actually a Test Excellence Group. It's Seth Eliot from Microsoft. Seth, welcome to STP Radio.
Well, thank you very much. Just anything excellence, that's just me. You know,
anything excellent.
I'll answer to that.
Your last name.
This is my middle name, yes.
I like it. Very cool. So actually, maybe some folks from the EEG, the Engineering Excellence Group, maybe describe just a little bit how testing fits into engineering in that group.
Yeah, so Engineering Excellence, EE, within Microsoft is really a cool group that Microsoft has this. Basically, we're not a product team. We're not producing product. We're responsible for helping the product teams do better engineering and produce better product, and basically working directly with the engineers to help them. So, like in the old days, it was a lot of training. You know, we'll creating and teaching classes. Yeah. And today, it's hardly any of that. Today, it's pretty much in-depth engagement, meeting with teams, learning what their needs are, learning where their challenges are, and helping them overcome those challenges to engineer better. Very cool.
And how do you actually, so you have people from all different disciplines within the company that now you're coaching and working with. So it's testers and developers, PMs, and the like?
Yeah, exactly. In the old days, it would be me and other testers and devs and other devs all on their own in group, and we'd go out and help testers. Now, the group I'm with is actually the data-driven engineering group, and it's cross-discipline, and I'm working with other testers, with devs, with PMs. So it shows the evolution of sort of how we're thinking about the disciplines and roles. But I still am very test-focused. I mean, in other words, so I'm still talking to folks about data-driven engineering, but I'm specifically like, you know, my area I like talking about is data-driven quality. Right. You know, how do we execute? How do we assess the quality of product? How do we augment or replace some of our old testing practices with data-driven practices? Data-driven
practices. Now, there's a lot of folks that will think from a testing perspective, they do maybe data-driven test automation. You're actually talking, maybe describe data-driven quality from how you connect a data-driven anything back into testing, because this is different than what other former folks might have thought.
No, yeah, I like where you were going with that, because I like to say to folks, you know, if you've been doing software testing, you've been data driven, unless you've not written any tests and you just sort of like, you know, look at the software and then say, yes, it's good, yet no, it's not good. You know, just sort of you get a gut feel. Yeah, that software, I feel that's good.
I like really that software.
I like that.
I don't like that one.
My crystals say that the moons have aligned and we should release. So, unless you're doing that, you are data driven. You ran test cases; those test cases passed or failed, and ostensibly that told you something. Yep. The fact is, however, what it's told us often has been murky. It sort of has been crystal reading in a way, you know. Yep. Oh, those failed, but that's a known failure, and these failed, and that's not so important because that was just a transient failure, and I think we're good to release. Yep. And that's not so data-driven anymore. So, you know, you could actually take data-driven quality in one direction, which is not the direction I want to talk about, which is take your existing pre-production traditional test cases and apply data science to them. A friend of mine, Michael Corning, a colleague, has come up with ways to apply something called Bayesian analysis outside the scope of this talk to test results, to a history of test results to tell you truly, are you ready to release or not ready to release, and not have to guess about those red-green, is it good, is it not good. So that's one form of data-driven quality. Now, where I've taken this is sort of another direction. It's sort of the evolution of what I used to call testing in production, or TIP, which is about using more production, or what I call production quality data. So meaning, production is obviously the data from real users in real environments. Production quality data might be sort of real users, maybe beta users, or maybe internal dog fooders, you know, things like that. So it's basically how production and how close you can get to production, and using that data, using telemetry, using user sentiment, using user feedback, direct feedback, focus groups, all of these, even customer service calls, understanding how if customer service is logging issues and finding patterns in that. All of these are data signals that any good software tester should be using to assess and understand the quality of their product.
Yeah. So when people say this call may be monitored for quality assurance purposes, that's one place that DDQ can jump in.
They should actually do that. Yeah. So, usually when you hear that, you don't believe it, but
sure enough,
they should be doing that. Yes. And it actually, the customer service data signals is an interesting one, because we'll ask groups of folks, have you ever talked to the customer service folks, or you ever reviewed the customer service data? And very few have, and that's leaving money on the table, folks. I mean, if you want to know about the quality of your product, see what bugs your customers are encountering, and they're actually bothering to pick up a telephone and call someone about.
They're actually taking action, which means they're probably quite relevant. Now, you used an interesting word here, which is not, at least to me, common. That may be a good way to start talking about data science applied to quality and testing. And this is the word signals.
Yes.
Expand on that. Like how can testers start thinking differently using this word? What do you mean?
I mean that, there's lots of think about raw data versus signal. Raw data is the data you just get that's out there, or you retrieve it, and you want to turn it into signal. Signal is something that is actionable. So an example is raw data might be telemetry data of when users start and finish certain workflows. Okay, that's the raw data, just monitoring and telemetry data. And the signal might be, you might take that data and calculate the 95th percentile execution time, or I might, for ease of use, I might say the mean execution time, or how long it took that to run. But means are not the best thing to use. But for sake of argument, we say we're using mean. So the mean execution time, or median execution time for this workflow. And now you have how long it took someone to open their inbox, say, for people around the world using a variety of browsers, for people on a variety of operating systems or mobile platforms. You have this data of how long it took to open their inbox, and you can slice and dice that data and find out the bottlenecks and just say, oh boy, on the iPhone, in the iPhone browser, this is taking way too long. Let's investigate what the problem is. And now you found a bug and you can get it fixed.
But using the sort of the metaphor of signal, it is actual signal as you describe it. There's more a meaning or a context applied to the raw data that you can now do something with, different than just having to have an appetite for reading lots of bits and bytes.
Well, exactly, yeah. So, as I said, in that case, the raw data might be just a bunch of timestamps, which is, in themselves not that meaningful. But you're going to have to then process them and do the subtraction to figure out what the time is for each user, and then do the calculations to figure out what the mean or 95th percentile time is, and then do the slice and dicing across the different platforms. So for another example that is non-traditional, so that timestamp is a very traditional kind of raw data that everybody can relate to. But a non-traditional one might be Twitter feeds. There's your raw data, Twitter feeds, and what the heck are you going to do with that? That's very unstructured data, right? And
and flamey.
Well, flamey can be, I was going to say good, not good, useful. Flamey can be useful if you're trying to find bugs and fix quality issues and improve customer experience, because you want to reduce the flamey. So there you go. You could actually come up with a flamey quotient, which could be your signal.
Well, you mentioned it before. It's like customer sentiment. I mean, there are the lexical and analytics that run on sentiment of social responses, right? Are you happy? Are you sad? And they look at language use and things like that too.
Exactly. Sentiment is the signal. So the raw data is a Twitter feed, and then there are many people out there doing this, calculating sentiment from that, which is not easy, as you said. It involves a lot of AI, machine learning type stuff, language analysis. But if you can calculate sentiment, that tells you things about your product, and then you could start, again, using that same kind of lexical analysis. Well, what is it sentiment about they don't like? Well, they really like, these people really like Excel, but they really don't like the time it takes to load a large spreadsheet. You can actually get that from a sufficiently rich data source.
Let me ask then as well, you can start, like you say, sort of slicing and dicing that data. Let's say you are opening a large Excel spreadsheet, and you can sort of maybe, if you have the source, is it a local spreadsheet or one shared via SharePoint? Two different locations. Obviously, we would assume one to be slower than the other, but you might not correlate it with these other elements of the sentiment.
Right, and correlation is one of the keys. You want to that's the kind of correlation you want to do. Another kind of correlation you might want to do, again, keeping with Excel. Excel actually talks to a lot of different web services, the modern version of Excel. Yeah. So you might have some error occur on the service side. You want it to correlate it to any telemetry we're collecting from the client side. So that's another kind of correlation you want to do. So yes, that is important.
Yes. So we have signals that we can sort of create and reuse. But I think for, let's say, a straightforward tester, as you kind of started discussing, how do I start to, if I can reach out and start getting access to the raw data, start putting some things together with some of the basic calculations, aggregations, and things, how does that change my sort of straightforward testing that I do today?
Yeah, I want those kinds of testers to think about what are they testing today. Like, so they're writing test cases, and I would call those synthetic test cases, right? Mm-hmm. Because they're it's not the real user doing it; it's a tester or some automation system running it. Right. It's usually being run with some sort of synthetic, made-up data. If you're doing it really well, you're actually doing it with data that you might have recorded from production or based on production data, but it's still synthetic. Yep. So then you got your synthetic test case. You could actually take something similar to that and try to assess what's happening with real users in production. So I don't know. I mean, if your test cases open up a new spreadsheet, just sticking with Excel, can you in production get data on when a user initiated an open action, which can be done probably several different ways, mm-hmm. and what the result was? As simple as did it throw an error, that's a start. Sure. But then more complex would be, did it complete? Did it actually open? Was data loaded? So that would be the first way to start thinking about it and start getting that kind of telemetry out there, because what you want to do when you start data-driven quality is think about what questions are important. What about the quality is the most important thing for me to know? Because just like when you're writing a test case or a test plan, I should say, you have to prioritize. You're not going to be able to test everything. So you got to understand what is most important for your product. It might be easier to think about it in terms of three categories that build upon each other. There's the system level, which is, is it available? How performant is it? What resources are being used? That kind of thing. Sure. And then there's the experience level, which is what are users doing with it, and what is the response of the system to their usage, like is it opening or not? What is their sentiment, like we talked about? Those are the two main categories. And then there's a third category, and this is sort of your advanced level one, which is business health level, which is ultimately what we're after, right? We're all writing and testing and engineering software to deliver business value. So is it actually acquiring new users? Is it actually making money? That's ultimately what we want to measure. The interesting story, so the OSG group, or Operating Systems Group within Microsoft, which was formed last year as part of the big reorg, which is Windows Phone, and Xbox. Yep. And they went through, after they reorged, they decided to adopt data-driven quality. And the testers there all had to sort of do this shift that you're talking about from this traditional mode. And Windows, a lot of especially the Windows folks, they're very traditional, right? They were PM writes a spec, and then the test person reviews it. Then the dev implements it while the test person writes a test plan and gets that approved. I mean, that was all very traditional Windows, right? Yeah. Now they're moving to this data-driven quality world. And these fellows actually were working, these particular assets were working on the systems that developers use to create apps. I think it was Windows apps, or it might have been mobile apps, might have been both. And they said, okay, so we're going to create some of these new functionality for these developers creating apps. All right, so how do we assess the quality of that? They're trying to get into this data-driven quality. Well, we can measure how many developers are using it, and we can measure, how easy was it for them to start up the SDK and create an app. And I said, yeah, those are good, okay, but you need to prioritize. What should you really measure? And we came up with, you got to really think this way. This is a different way of thinking for a tester. Mm-hmm. Can you put these old one and the new one side by side and see whether apps made with the new SDK and APIs make more money than apps made with the old one?
So that's very interesting.
Testers are not going to think about that. I'm going to measure how much money was made with the product. That's way out there. That's crazy talk, right?
It's not typically what you would define for like an integration test, a functional test, and the things that were part of app development lifecycle like you described in Windows. But I do think it's very common outside of a QA group that there are people always doing A/B market kind of analysis or sales interaction usability analysis that hasn't traditionally been part of your institutional QA or tester role, even in an agile sense, even though I think testers maybe got more exposed to those business needs once we got integrated into more agile direct business interaction.
Yeah. Yeah. Well, there's like three things in there I want to address. I'm trying to decide which one. So yes, absolutely. And very often those kinds of A/B tests were focused very much on design and very, user facing features, and not so much on the back end and the actual